Good afternoon, everyone. My name is Olga Kane. I'm a managing director at Synthesis. We're a quantitative hedge fund, and we use machine learning, artificial intelligence, and big data in our investment research. And I'm very excited to be here today and to moderate a panel on such an important topic. Throughout the conference, you've heard a lot of conversations about the benefits of AI, about use cases, maybe even about the cost of AI. But to really assess the value that AI brings to the financial services, we need to consider value of AI and the benefits it brings in the context of what we invest to make those AI programs happen. I mean, is it really worth it to build those AI projects within the company or invest in buying them? And I have an amazing panel of experts today from different companies that play different roles in the financial market. And so we'll be able to discuss this topic from very different angles and use cases. So I will ask the panelists to briefly introduce themselves. What's your company? What is your role? And what are your areas of interest when it comes to AI? Sandeep, let's start with you.
Thank you. My name is Sandeep. I work for Synechron. Synechron is a tech consulting firm. We work for banks, hedge funds, all sides of the market. I get to run the labs for the company, financial labs, FinLabs. We have about 100 people team. We focus on DLT, data science, all focused on the banking, financial services use cases. Very happy to be here.
My name is John Ashley. I'm the general manager for financial services at NVIDIA. We support our customers, many of whom are in this room, in their adoption of accelerated computing, accelerated networking, across a lot of use cases, but we're really here focusing on the AI side of things. And in a past life at NVIDIA, I also formed our AI consulting practice and our AI consulting partner program. So I'll put my old hat on sometimes for this discussion as well.
Hi, I'm Ed Tong from the Applied AI and Machine Learning team at JPMorgan Chase. So I'm a data scientist by background. I lead a team of machine learning engineers, data scientists. The goal is to apply machine learning models, develop and deploy machine learning models in production for the operations lines of businesses at JPMorgan. That would imply markets operations. For example, all trading activities, fixed income equities, from the operations angle, making sure our trades settle on time, for example, finding the right inventory. We're also covering security service operations. So JP is one of the largest custody banks in the world, along with BNY. And we have a lot of machine learning opportunities in the custody banking space as well. The line of business they're involved in is payments operations. So any type of cash transaction that occurs with corporate institutional clients, hedge funds, and sovereign wealth funds, we have machine learning models there as well to help more efficient cash transactions.
Hey everyone, my name is Rajiv Sambyal. I lead AI machine learning and blockchain efforts at Bank of New York Mellon. I'm part of the digital assets unit over there. I think from the application point of view, we are using AI machine learning. Like not many people know, I think we were having the discussion the other day that banks generally are not seen as the hotbed of AI machine learning, like not Google and Microsoft and all, but we do quite a bit of work in AI and machine learning, and as well as digital assets. So all the crypto geeks sitting in this room, right? So I know it's not a blockchain conference, but later on we can definitely talk about that also. Happy to be part of this panel.
Thank you. Thanks. So ROI, return on investment. Why don't we start with talking about R? How do you measure return on AI program or AI algorithms? It's more or less obvious when we're talking about alpha generation and trading. But when we're talking about banks, working with clients, improving operational processes, how do you really measure that return?
I'll take a stab at that. I think one of the questions we have to think about is the time horizon, right? If we look at these data science projects, especially in the customer space, they're very data-driven, and if you put the processes in place to continually improve your data, then the process is going to continue to improve over time. So when you launch your project, right, the first month, it may not lead to a huge change. but you may be able to improve the quality of the data, continue to build on that. So over time, the return on that investment is going to be growing. And so I think it's a more complicated question than it is for a typical programming problem where I write the code works, it goes in, and maybe 3 months later or 6 months later, I'll do an update. Right? This is much more dynamic. Return is frequently associated with changes in customer satisfaction, improvements in the customer experience. So a lot of time the measurable R shows up downstream in customer churn months later. So it's tricky, right? Justifying the return, especially on the early projects, can be tricky.
Ed, what about JP Morgan?
Well, if I give you the operations angle on that, so essentially to follow up on what John said, so we're focused heavily on reducing manual work done by our staff. So trying to get them, moving them away from very mundane manual tasks, letting them focus on more higher value tasks, interacting with clients, improving the client experience. So machine learning has really helped there to automate, or at least partially automate, if not fully automate, many manual tasks within the bank. Some examples of email automation. So you can imagine the volumes of emails that JP gets from our various clients, and you can spend a very long time manually sorting through emails, categorizing emails, extracting information from emails, or you can use appropriate NLP, NLU type algorithms to extract useful information from there. So in terms of reducing manual time, cost savings, another big one for us is reducing regulatory penalties. If we can develop a machine learning model to predict the timing of an adverse event, if we know something bad is going to happen, we can take early action, reduce that event from happening, and reduce our regulatory penalties associated with that.
So if the return on such an investment is not that easy to measure, so when your companies decide which opportunities to pursue, how do you present? So I'm assuming there are committees of people in such big companies, right, who make a decision where to allocate the budget. How do you prioritize the opportunities if return on that investment is not that obvious?
I can take that one. So I think, as you can imagine, right? So we get a lot of requests or projects come on our plate that can we apply machine learning, right? So at any given time, we have tons and tons of projects coming in, but the resources are limited, both money-wise as well as people, right? So I think at least the way we work is, I think we have certain criteria we go with, right? So we have a framework defined. The first thing we look at data, right? Look, the heart of this whole AI machine learning is data, right? You can come with hundreds and hundreds of problems, but I can tell you a lot of those we actually have to just say that we cannot work because the data is not there. There's not enough data there, whether you call it labeled data, unlabeled data, whatever is there. The data is just not there to be able to train some of these models. So that's the first criteria. The second process is actually discovery, right? A lot of times you have the data, but the problem is just not suitable for machine learning, right? So machine learning is not a panacea for everything, unlike a lot of people think. You can't just take machine learning models and patch it up with anything, right? So I think if most of us are applied machine learning people here, right? So some of those are application problems which come to you and say, okay, these are application problems, just do a code fix and you'll be fine. You don't need the machine learning for that, right? So the second, that's the discovery piece. So once you are past these two, the third thing we have is actually the business outcome, right? What Ed was referring to. What is the problem it's solving? Is it a pet project? Somebody in the corner is going and churning out models. We absolutely do not want that, right? So before we actually take on a project, we make sure that there is a business sponsor against it, and that business sponsor has value against it, right? Look, that value could be short-term or long-term. There's got to be some value to it, right? So sometimes the value cannot be realized in 6 months. It could be a year. But you got to have some business outcome and business value to it. I think once it passes this litmus test of 3-4 things, then we say that, okay, we'll take on this project and we'll work on it. But without all of these things in place, we just don't take it.
Mm-hmm. Mm-hmm.
Yeah, and one thing which is like a negative test we do is the returns could be incremental, use case, business benefits. But what should not happen is it increases the risk in the process. It feeds into some decision making which could, because all these AI models work on data. It's not just like a software precision issue. It's a data issue, and it could unsettle things which is not under your control. So many times we try to see that it should not be risky. Start to take the less risky projects first, show the value, and then graduate to more risky projects. So the risk also plays a role in those decisioning.
Mm-hmm. So we talked a little bit about the R in our ROI. And now I suggest we spend quite some time talking about the I part, because that's a big part of the discussion. Probably one of the biggest spendings when it comes to developing AI algorithms, it's obviously data. Apart from just acquiring data and getting the data that's available or making it available, what other costs or expenses are associated with data preparation, with data ingestion, and so on?
I can start. I think maybe next time I'm gonna bring my head of business over here. That they're the ones. He's the one who's allocating the money. Investment is definitely a big part of it, and it's just not about data scientists, right? It's about data labelers. Like it's very simple. People do not think about it, right? A lot of these NLP problems which you're trying to solve, I'd refer to email. We process thousands of documents, right? Like for a bank like Bank of New York Mellon, say, I'm pretty sure JP is the same thing. A lot of it needs labeled data sets. So you need people to be labeling data. Unfortunately, I can't go to Amazon and use Amazon Turks. It just doesn't work, right? Risk teams are going to be after me for that, right? So there is a cost there, right? So then there's a cost to build the models. So there's a cost to maintain the models, right? So from a cost perspective, so initially when I was talking about the business-driven kind of projects, so its investment is part of that, right? So return is definitely there, but does that investment return like weigh in on that, right? So we have to consider it's just not building two data scientists working in the corner and doing it. You have to productionize the models. A lot of people fail to understand that machine learning is not just about models. There is a solution aspect which goes along with it. So you need to have engineering with you to be able to deploy it. You can have 3 data scientists churn out models, but I can assure you they won't get deployed anywhere, right? So you got to have your engineering and solutions behind you. So there is a cost element to it in actually productionizing all these models. Otherwise, it'll be just experimentation.
Of course. And I think the other thing with data, a difference again with a lot of more traditional projects, you're not going to just touch that data once. You're going to go in, you're going to get the data, you're going to clean the data, you're going to label the data, you're going to do the first iteration, you're going to realize you didn't label it right, you're going to realize there's other problems, you're going to train your model, you're going to repeatedly access this data. So if you need to think about what's it going to cost me to store it and access it and keep moving it around, which means your existing data storage solutions may not be appropriate for that level of access to that much data. Your network might not be set up to get it to where your compute is, right? You need to think about, hey, well, how am I going to get my compute and my data close enough together that I don't spend a fortune moving one of them to the other all the time. Mm-hmm. If you're in the cloud, you have to pay sometimes storage fees, depending on your agreements. So I think there's a lot of costs just on the data side that we don't think about at first. But once you've done one project, you never forget them because they come and bite you hard.
Yeah.
Just to follow up as well on Rajiv's point about the engineers. So you talk about data engineers for ingestion, the data scientists for developing the models. You have machine learning engineers putting them in production. We also have production support engineers. So for example, we have models that run 5 days a week around the clock, making predictions in close to real time. We need a production support team that can actually monitor the performance of these models. If the model goes down, we need to restart it again. So we have teams of engineers that really sit around the clock geographically, all regions, just to make sure these models are pushing out those outputs as we expect them around the clock. So another aspect of the investment process.
And if you connect it to the life cycle of an AI project, suppose you have taken 10 weeks to do a POC and MVP and so on. It almost takes 10 months at that scale to be able to productionize and stabilize. So you have to take up the entire pod cost, running cost, cloud cost, and be able to sustain over a very long period of time at a much higher scale to be able to run it in production. So it is almost 4 or 5 times whatever you did in your POC stage.
And I think one of the things we see there is the first AI project you go to justify, the investment is going to be staggering if you just look at it all as, hey, this is one project. Because you've got to build all those processes. You've got to train those people. You've got to build those teams. They have capacity to support probably more than one project. So that investment is really, but the way banks work normally, one business owner is going to have to step up to that whole investment. And I think that's been a blocker for a lot of firms because the one business owner is like, I can't step up to this whole thing. And yet only a quarter, a tenth of it really will be that project in the future. That amortization can be a challenge sometimes.
Thank you. Now, I really want to talk more about data engineering because it's definitely a very big problem in my own practice. It is still manual. I know some data vendors I work with, they have attempted to use AI for data preparation on the data preparation stage. I have a funny story about it. We once came across that error in the data where the article in the news related to some delivery of some apple, the fruit, was mapped to a PPL ticker. I'm just hoping that was AI. But my question to you, from your practice, from your perspective, where is AI in terms of being used in the data preparation stage? Can we ever really get rid of this data engineering problem by using technology?
So actually, it's good that you mentioned that because we do see these data quality issues you described definitely common in with the huge upstream data sources that are part of very large investment banks. We do have anomaly detection algorithms that essentially pick out data quality issues at the beginning of day. So start of the morning, an algorithm can run. It can scope through millions of data points and figure out if there are any anomalous transactions and anomalous data points. And if there's a problem with the record, where else should we look? Is there an alternative data source? Is there a trusted data source that we can defer to? But in a lot of cases, like with the algorithms not being built, it's really important to have very, very efficient data pipelines, monitoring data quality, and knowing where your subject matter experts are as well. If there's some issue with the data, there's someone we can refer to in a upstream tech team or in the business line to verify those data sources. A lot of the times, if you're seeing anomalous outputs in your algorithm, I mean, there's a fair chance there's something happened in the upstream source system, and you just didn't know about it.
Yeah, and if I connect, we work a lot in the capital market use cases, and there you are not just dealing with structured data. There is a lot of documentation, complex agreements, can run into 300, 400 pages. Each deal is different, as the business would tell you, like don't try to automate it. And even if the task is simple to extract 20 data items from this, you'll start failing. So one of the approaches we have taken is not get tied up with one specific vendor product in this area and keep trying a lot of open source products. They tend to, like the Googles of the world, they do a very good job in the general universe. And in the lab, we try and apply that to financial services documents. That approach has served us well, rather than get tied up with a product which was very popular, cutting edge in 2017, and then 2 years later, it's not even giving you 50% accuracy because of the complexity of the documents.
Yeah. So look, I think labeling and getting the training data is definitely a big problem. I can tell you, like there are a lot of fintechs. I mean, almost every other week I get to meet a new fintech, right, who's working in this space. But so far, like at least I have not come across a company or a product which has been able to solve this problem. because they work on very specific use cases. Yes, they're able to do that, but you can't generalize that. At least I've not been able to come across anything like that. We internally are doing a lot of research around this also. One way we are trying to solve this problem, I think, structured and unstructured data, at least for structured data, we are trying to see if we can do synthetic data generation to get around this thing, right? So there's a lot of research and in even academia, right? A lot of research has happened in this area. So that's one thing we are looking at. Like, can we do synthetic data generation at least for structured data to get around this problem, right? But at least I haven't come across anything, right, which can solve this problem today.
I think one of the key things there too is, right, data labeling, data cleaning, all this stuff is not a project, right? It's a process. And you have to think of it as, where's the feedback loop? How are you, as you go through the training, are you doing the hard negative mining? Are you trying to bootstrap things, right? Are you looking at how your model applies back to itself? Where's it making errors? Let's look at those errors. Let's figure that. To your point, where the model makes an error, chances are it was given bad data. Let's look at those bad data points and let's see if those, right? So we can at least focus the human's attention. Mm-hmm. We have that. Synthetic data is a great thing too, right? You can use that if you can build that practice. You can use that to flesh out those areas where your data is weak or potentially poorly labeled, and maybe help bootstrap yourself a little bit. Mm-hmm. So I think you can add some automation, some augmentation, if you will. You can let the human data labelers do more interesting work, mm-hmm. but I don't think you can get them out of the loop.
Yeah. I'm thinking right now maybe at some point we can crowdsource labeling like Google does with CAPTCHA.
Mm-hmm. Banks.
You can't log into your Robinhood account unless you map some tickers or like label some data points. Okay, so as of now, it is still a very manual task. And we all need good data engineers. And I don't know about you, but I'm personally struggling to hire data engineers. And the reason is mostly that they don't consider this job attractive, right? And it's not only about the money, they just don't consider it interesting and attractive, especially younger people. They want to change the world, they want to build AI algorithms, they want to build machine learning algorithms. How do you deal with the talent retention and talent acquisition when it comes to data engineering?
I can start. So a couple of years ago, I would say this was absolutely a big problem. I remember, I think 3-4 years ago, a similar conference. I used to have college graduates who were about to graduate. They could not understand the difference between what does a data scientist do, what does a data engineer do, what am I going to be doing? Am I going to be writing APIs or I'm going to be writing SQL queries? Big confusion. I can tell you that right now the situation has changed a lot, right? So people at least understand at least a lot of it, right? Not everyone understands still, but what is the job of a data engineer? What is the job of a machine learning engineer? And what is the job of a data scientist? At least like that people understand, and students are graduating from the college understand, because over the last 4 or 5 years, right, a lot of colleges are actually offering these courses, which is making it a lot more clear than what the jobs are, right? Now, to your question about the talent, and also internally, also within Bank of New York Mellon, also, so we have track, right? We have a path where, so typically what we have seen is people who are strong in engineering, especially in the data background, right? They tend to be a very good fit for data engineering role. I'm not talking about data labeler. So again, there's a confusion about data labeling and data engineering, right? Data engineers are not data labelers, right? So you don't want engineers to be doing the labeling jobs, right? That's a different kind of skill set. So that's one track, which at least I have seen that you take your strong data side engineers, core backend engineers, and they have interest in being a data engineer and working with data scientists to be able to do that. So that's the progression we have done, and also when we hire graduates, right? We have a campus program where we get a lot of young graduates, and we give them the option, right? You want to try being a data engineer, or you want to be a full stack engineer or a backend engineer. So they get to work on a few things, and then based on the interest, they can choose. Forums like these are really helpful because I've seen a lot of students coming to these forums and asking questions about it, and they get some clarity, and then they can make up their mind what they want to do about it.
Mm-hmm.
One thing we have tried, and we are still through the trial phases, if you give technical people some options, how they want to spend their month and weeks and in a day. So for example, we are trying giving them open source projects. So if, apart from doing the proprietary work all day long for a bank or a hedge fund client and gaming companies and cryptos and so on, there's a hierarchy there. If they get to work on some open source projects, contribute, and that's like equivalent to writing white papers, etc. They get some kind of glow from those open source projects, that community, that approach, and which is not so common if you're working in a hedge fund or a bank and things like that. Things are very restricted. But in our lab, that kind of approach works. That helps retain people and attract some of the younger crowd. We joined an organization called Finos. They're one of the largest open source organizations within the financial services world. So those things are helping us a little in this aspect.
And just to continue our conversation about data, one of the big impediments with data availability and data usage is data privacy and ownership. Obviously, no one, especially big companies, we don't want to get in trouble with that, from the legal and compliance perspective. However, like in my personal practice, for example, if I collect data of institutional investors, now that concern is valid because it's more or less easy to reverse engineer and to identify that specific institution who performed that trade, right? But when it comes to like retail investors, when it comes to individual data points, like there are, as far as I'm concerned, there are methods out there to really anonymize that data, to randomize it, to make sure there is no way to reverse engineer who those people are. Not to mention that for someone like for example, hedge funds, for someone who uses this data for alpha generation, that is completely irrelevant and we just don't want to know. But for some of your use cases, that might be even a bigger problem. And obviously some data owners, when you're trying to make that data available, when you're trying to productize, to monetize your AI product, that can definitely stand in a way. Is there like a more or less easily explainable methods to bring it to like legal people, compliance people, and to be able to use that data?
So one of the biggest problems, like if you have a hedge fund wants to access to retail data, let's say credit card data, mortgages data, they want to run modeling, they want to see the trends, but at no point in time, they should be able to see the underlying data, the PII information. It's one of the biggest problems in the financial industry. So one of the approaches we have taken, and we work with a fintech called Leap Year, in that they apply a technique called differential privacy. So they introduce certain kind of noise in the data, but the noise is so much calibrated that it will not change your aggregates, your analytics, and things like this. But they mathematically guarantee that data set cannot be reverse engineered. And they have gotten some approval, so we work with them. In cases, imagine you are doing some model development work, you are able to see, like your modeler should not be able to see the house ownership data and credit histories and things like that. Even within the bank, the other LOB should not be able to see that. So those kind of techniques like differential privacy has helped us progress those projects.
That's great to hear. That's some really cutting-edge techniques being used. At JP, I'm very fortunate to have a very large legal compliance privacy team. So before we embark on any AI machine learning project, we essentially supply sample data with sufficient granularity and transparency. And we go through, depending on what legal opines on us, we have to go through an anonymization process. They'll be checking the data set for biases as well. So perhaps we just can't use certain features for bias reasons. But we definitely have to clear that counsel before we can embark on any type of AI activity. But what what Sandeep suggested sounds quite cutting edge for anonymization.
Yeah. We see a couple of things in that space, right? So federated learning is an area that's getting a lot of research. Healthcare is really far ahead in that space. I think they have some advantages in that a lot of times the different data sets they have, they can't leave the hospital or the healthcare environment. But they all got collected off the same kind of X-ray machine, or it's the same kind of medical imaging. I think in finance we have a little bit trickier problem because sometimes we have consumer data about cards and consumer data about mortgages in different places. Plus we have a lot more of the data sovereignty issues, right? The data about my French citizens can't leave the EU, right? So we have a bigger federated learning problem with both vertical and horizontal aspects. I think there's a lot of research going on. People have successfully done projects there. Even, you guys, Bank of New York Mellon did a talk with a fintech about using like homomorphic encryption. So it's provably, they can't see other people's data, but the other people can share the data for training. These techniques are all pretty cutting edge, and they are compute intensive, so we like them. But they are starting to be applied in real world problems.
Do you think educating like legislator and legal and compliance experts about the methods to anonymize data, do you think that'd be helpful in like regulation, data regulation?
Yeah, I mean, these reg tech bodies, etc., they are getting a lot of tech talent inside them. When we run a, let's say, off-topic DLT project, we make sure one of the nodes is reserved for a regulator as well. They should be able to see certain types of data, etc. But they look for guarantees, like how do you guarantee this data cannot be seen, cannot be taken outside the country, etc. There are techniques like confidential compute. We are doing some projects in the area of confidential compute where it can be mathematically and hardware-wise proven that that data cannot be even seen by the processor itself, even the processing company. The biggest, I mean, AWS is so popular, but they are the biggest threat to your data. So Microsoft has that confidential compute environment where even the data cannot be seen by even the processor. Only the machines will see that data. So some of those techniques will help. I mean, I do not see this as an educational issue. It is a technical challenge. How do you prove this to regulators?
Right.
And
I guess this actually found a point we disagree a little bit on. This is awesome. I actually disagree a little bit. I think there's a technical challenge. I agree with you there. Yeah. I think there's an educational challenge. I think in the vast majority of cases, if I was to go with a customer of ours and we were going to go talk to their legal team, and I started throwing around terms like differential privacy and homomorphic encryption and vertical federated learning, I think I would get thrown out of the room really fast. I think it's, there's an element of education. There have to be the rigorous proofs because there will be someone that legal goes to, a professor, a regulator, someone that wants that. But there also has to be, I think, an element of education about where each of these techniques puts you on the risk scale and how much of it is necessary to get you where you need to go.
I actually couldn't agree more with that because that's exactly my experience working with data owners. When it comes to a company that owns the data that I would like to use, it really takes a while to even explain how the data is going to be used, and they also need to calculate their ROI, right? I'm willing to pay a certain amount of money, but like the risks they're taking in terms of data privacy, they really need to assess it. So let's imagine that we are in a perfect world. We found good data source. We have a good model. Everything is working, backtest, everything. But going forward, it's not just a static process, right? You need to perform model management. You need to check your data every once in a while. And if something goes wrong and the performance of the model is not as it's supposed to be, you need to figure out, is it a model problem? Is it a data problem? Maybe at some point the task itself changes and you need to apply a different model. Talk a little bit about your process of model management and data management.
I can start. I think one of the major things I think which at least I see, which is not given enough thought, is the feedback loop, right? So you build a model, that's fine. You deploy it in production. Like then what? After 2 days, ops comes running to you or business comes running to you with predictions are like gone for a toss. What do you do, right? At that point, you realize, okay, there is no way for you to pull the production data down because I can't go in and, at least in the bank, right? Like I don't have access to go log into the production and start digging around the data, right? So one of the biggest things, which is an afterthought in a lot of cases, is the feedback loop, right? Every data science project which you do, machine learning project you do, you got to have this beginning, because I can tell you that just from experience, that's the toughest part, right? Data scientists are awesome. We can solve the model problems, right? But the biggest challenge is actually the feedback loop, because it's not a data science problem, right? It's a data engineering problem. It's a core engineering problem. It's an infrastructure problem, right? How do you take, and it's a privacy problem, right? How you take the production data, put it in the QA region, how do you train it? So I can tell you that a lot of our time, at least like my team's time, and I spend time in creating those feedback loops and going back to the education internally, telling people and businesses that why is that feedback important, right? Unless you want to, at least I have not seen a model which you deploy once and it runs forever. So that's where the model maintenance comes along, right? That feedback loop is extremely, extremely important, and it cannot be an afterthought. It's similar to like security cannot be an afterthought. Feedback loop cannot be an afterthought.
When you refer to the feedback loop, you're referring to like the end users providing
exactly,
feedback.
and capturing that data, right.
That's great. Yeah, so that's actually raises like important considerations around like the UI as well.
Yep.
Making sure the UI experience is good.
Correct. Absolutely. I mean, you run into instances where like users are seeing it, but it's not editable. You can't. So that's what I'm saying. It's not a data science problem. Going back to it's a solution you are creating, right? So you're not just solving like a model, right? Machine learning model. So I think that's where it's important to have this holistic view of it.
Yeah, there's that change management piece there, right? My job as a person in the loop may change from doing the work. Now I'm supervising the work.
Correct.
And that means I have to provide feedback and coaching to this AI algorithm. And that frequently gets forgotten. And it also, just the change management and the training of people to understand why they have to do this, why that's important. That's an upskilling thing.
Yeah, and that's why you get drifts, right? So that's why drift is a very, very common problem. Like most of the people who deal with production machine learning models, it's a very, very common problem, right? And the reason being, like after 6 months, when you realize this, what do you do with it? Because you don't have the data, right? So then you start the fire drill of pulling the data down, retraining it, getting So that's why that has to be thought through. Granted that you have good model change management process, right? Like to John's point, right? So you have a process, like you have MLOps is a very common word now. It wasn't there like 4 years ago, but now I think everybody has heard of MLOps. You have DevOps, hopefully you have MLOps, because otherwise your developers are, putting something on the console and throwing it in production, so you don't want to have that, right? So you got to have those pipelines in place to be able to do that.
Yeah, and as part of model ops, we always try to have a challenger model running in a similar environment, et cetera, so that sometimes you can get some heads up about things going wrong, and before actually things blow up and business starts telling you. So those kind of things helps you manage the drift a little bit proactively.
Yeah, I think the other thing that, with these data science models, unlike a traditional piece of code, you can check the boundary conditions. A lot of cases, the data science model is going to give you an answer. Whatever happens to the input, it's going to give you an answer. And so figuring out where the guardrails have to go around your input and output set I think is important, whether it's a challenger model, whether it's an explicit set of guardrails, something. You've got to put those in.
Or an exceptional workflow, which gets triggered out of this.
I was actually going to mention as well, Sandeep's benchmark model idea, challenger model idea is very on point. Preferably develop one with a completely different methodology, maybe a little less complex, something more interpretable, and that will help you diagnose any issues you might find if you're running this one in parallel. And also very much having an ongoing monitoring process for your data, trying to understand any distributional shifts between the baseline. When you actually develop the model at baseline and the current time sample, looking at distributional shifts, looking at statistical metrics like the PSI, the Population Stability Index, how much is the sample changed proportion-wise and numerically continuous-wise, that will give some early warnings on drift.
Yeah, and one of the problems in the industry, including me and banking executives, et cetera, is we started coding, working 20, 25, 30 years ago. Many of us were brought up learning database, C++, all deterministic systems. There's a right answer and wrong answer. In the AI world, there is nothing totally right, totally wrong. So that, like, a lot of these departments are headed by those folks, including...
You are aging us, right? So.
I see the gray hair everywhere. So that, like, the earlier you get used to doing this, you know, like the way you started dealing with NoSQL, schema-less databases a few years ago, et cetera. So that kind of diversity in your team also helps. You cannot have only one type of software people. You need to have people who understand R as well, who understand things which are different.
And by the way, since we're talking about return on investments, I can imagine that a lot of companies, they just don't think about the cost of maintenance, the model. Or if, for example, the data is no longer available, then like everything that you invested in building that model, in acquiring that data, there's a sunk cost. So it's also an important consideration. Now let's talk a little bit about the infrastructure. How to pick the right infrastructure to maximize the benefit of the AI program, but at the same time to optimize, I'm not saying minimize, but to optimize the costs. I mean, like cloud or server, data lake or data mesh. What are your comments on that?
Well, I'll quote our CEO, right, and some other people, right? Buy the base, rent the peak. That's always a good guideline. But I think the other piece that the whole cloud on-prem, right, we don't see it as a debate. You're going to have both. Mm-hmm. The key point, though, is what you probably cannot afford to do is keep moving data from one place to another. So you have to send the compute to where the data is. If the data is on-prem, the compute's got to be on-prem. If the data's in the cloud, the compute probably has to be in the cloud. And just, the debate, you shouldn't be having a debate. There shouldn't be a discussion there. Where the data is determines that. Then you can optimize your infrastructure. And that's balancing your compute, your storage, your networking for the kind of problems you're going to do. If you're working with market data and doing lots of historical backtests, you're going to be streaming a lot of data. But it's tabular data. Mm-hmm. If you're working with images or text, well, you're going to be streaming an awful lot of data. And it's a little more complex sometimes to stream it because it's not as nicely sized or as nicely formatted. Mm-hmm. So I think you have to really dig in. There's no optimal one-size-fits-all data science piece of infrastructure for every problem that a bank will see. You need to kind of, you can optimize for the biggest, hardest problem you're going to see, and it'll handle the little stuff okay. Right, so if you optimize for NLP, you're good. If you optimize for not NLP, you'll save some money, but then when you go to do an NLP project, and everyone will, right, that's coming. If you aren't doing it now, you will be. And we saw earlier presentations. If you're working with BERT models today, that's great, that may solve your problem, but I guarantee you there are people trying to solve that same problem with a model 10 times as big, and with half the error rate. And if having a good answer is a competitive advantage for you, you're going to be doing bigger and bigger models. So.
And you mentioned arguments. Are there actually in practice arguments between different groups, maybe within a company, which piece of infrastructure to use for a particular product?
There would never be arguments like that, would there? It never happens. Yeah, we see that all the time. I don't know if you guys do.
I have no comment on that.
Okay. And not about the arguments. Like, what about your comment and like approach to infrastructure in general?
So look, I think, I mean, look, we run GPU clusters on site, on-prem, right? Look, as a bank, we can't put all the data on the cloud, right? There is some data which is just important, confidential, concrete. Like, there is no way we're going to be able to put that, right? So that's why we have infrastructure running on-prem. I think more than infrastructure, it's also, see, one of the things which I think a lot of companies are challenged with, where is the data, right? Because the data is siloed. So I would say that before running after setting up like a GPU farm on-prem, you need to solve your data problem first. Get the data in a place so that you can actually access the data and use it, right? There definitely, look, we run adversarial network models and we run like BERT models and all that stuff. So we definitely need compute, right? But we also need a central place to be able to access the data, right? So I think it's both sides. So compute is there, and you can choose cloud or on-prem depending upon where your data is and what your data is. But I agree, right? So the compute and data needs to be in the same place. You cannot be shifting terabytes of data like to cloud real time when your models are running, and also where your production is running, right? I mean, what we also consider or take into consideration is maybe if we need heavier compute, we build on a certain infrastructure. Production is in a different infrastructure because it doesn't need the same level of compute. Then there is a consideration of what libraries you're using. I mean, you're using NVIDIA architecture. It's a completely different architecture than if I use some other GPU, right? So there are a lot of considerations which we have to do, because what you cannot be doing is you're developing on, and it actually is there, right? So if you're developing on a certain GPU architecture, that GPU architecture, if it doesn't exist in production, like in production, you don't need GPUs most of the times because training is where you need most of the compute, right? So your models need to work on a vCPU environment rather than a GPU environment. So you have to code the models in a particular way to be able to do that, right? So all of that you have to consider to be able to do that.
Do you have any comments on that, on the infrastructure part?
Yeah, it's a complex question. I definitely want to look at like how complex of a model do we need to start with to solve this problem. And if we want to add additional complexity to your ML or AI model, we need to justify that with dollar impact. So the model is going to be more accurate by X%. What is that actual dollar impact? And then we can think about the right infrastructure for that, for example, being on cloud. And JP's heavy in cloud migration, a lot of projects moving across, but it's still not making sense like every single model being migrated to AWS. So we're still seeing a mixture of both.
Sandeep, what about you?
I mean, we operate at a software stack mainly. And one of the challenges I have seen when clients are making a decision between cloud, on-prem, where to keep data, et cetera, is handling of what they call MNPI, the material non-public information. They deal with a lot of third-party systems. They use packages and things like this. Not all of them are ready to go to the cloud at the same time. So there are many complexities which let you decide which model of infrastructure to choose, cloud, on-prem, where to store your data, it's a very complicated question, in my view. And I mean, the solution is having smart people who are able to think 3, 4, 5 years down the line, and then give you the advice how best to do it.
Thank you. And speaking of smart people, we have 5 minutes left, so I think that'd be great to take some questions from the audience.
The smarter people.
Not too smart. But I have a question regarding EDMC cloud standardification, and what do you next question is about quantum computing. Where do you see quantum computing?
Very good. Somebody dropped the ball, the big thing, quantum computing. I'll take the easier one. So there are a lot of organizations, EDM Council being prominent. They are trying to set cloud standards, et cetera. And the benefit that I see is, as a bank, as a hedge fund, you are trying to deal with a lot of fintech companies. Many of them do not know how to run things in production in a bank. They are trying to set standards so that these fintech companies can build these checks and balances within their products. So when you bring them in-house, there is less checkup that you need to do manually. Those products are configured, designed in such a way which will cover all the security checkpoints that you check. So that part, quantum computing, anybody who wants to take
a stab at that? I certainly can. But.
Yeah, I mean, look, see, it comes, so quantum computing as a play thing is different, but using as a production thing, I think it comes back to, can we justify using, I mean, we can still solve problems with our GPU computes and all that, right? So that's where I think at least we are not seeing any use case directly in production being used, right? It's definitely there, right? But the kind of infrastructure you need and the use case you need are very, very different, right, for that. So I would say I think that the workloads we have right now from a production point of view definitely are solvable with the infrastructure we have. Are we looking at that? Absolutely, right? Are we doing some experimentation and all that? But I'll just leave it at that, right?
So I think from our perspective, right, quantum computing is likely to be another accelerator technology in your toolbox for some use cases. The big use case we see everyone looking at is post-quantum cryptography, right? So that's a big use case. I'm not an expert. I'm not going to talk about it. But it is out there. Everybody is looking at that. Within the more computational finance kind of applications, I think people are starting to look. Across the board in the sciences, people are starting to look. There's very few real quantum systems out there. We actually just launched a package recently called cuQuantum, so where we can use the GPU to provide parallel simulation of quantum systems. And so if you wanted to set up a quantum computing lab, right, today you're probably going to have a simulator of some sort, and then you may have a link with one of the companies that actually has stood up a quantum computer, either a startup like IonQ or IBM or Google or whatever. But you're going to be doing a mix of simulation and toy problems because that's all there is today. But people are looking at it. It's an interesting area.
Yeah. Some banks are just like following up. Some banks are like putting some like big names in the newspaper, HSB Bank, like, oh, we are doing quantum computing right now.
So, yeah. So the joke in our firm is, like back in 2015, when everybody was putting blockchain in with their brand name and saying, hey, so-and-so testing blockchain, that seat is being taken up by quantum. And I'm hoping, like, we are dealing with AI, that is good enough. We'll deal with DLTs, good enough. Quantum, maybe the next generation will deal with. It is that hype.
Gonzalo from My Data. So some of the key takeaways of today is that AI is uncertain. It will take a lot of time to prove the ROI, a lot of time to maintain, not to mention the feedback loop and so on. So yourselves being AI innovators and advocates, how do you convince your peers or your customers that this is a practice worth investing on, and eventually the ROI will be positive?
So I can take that. I think you said a couple of things. So one thing which caught me was like, so I don't think we are saying that AI is uncertain, right? It is a proven technology, okay? And we have projects in production. We have products with positive returns to prove that out, right? So we don't have to prove that. But at least from my perspective, what I'm saying is that before you pick up a project, you need to do your due diligence. Not every project is an AI project, right? So it could be And it has happened, right? You can do a code fix, right? And you can create an application and not make it an AI project. That's one. The second thing, from a maintenance perspective, right? Like any software project, it needs maintenance, right? I mean, mainframes have been running for years and years. I don't know if any of you have dealt with mainframes. Mainframes, like, they also need some patches here and there, right? So there is a maintenance aspect to AI, which a lot of people do not realize, right? So AI is not something you deploy once and the robot is going to run and do everything for you for the next 50 years, right? So that's what at least we are saying, that, look, when you are picking up a project, make sure you do your due diligence, make sure your stakeholders are aware that if they give you $100, that's not end of it, right? They need to have, while they are reaping the benefits, they also need to spend $1 every year, right, to be able to make sure that it is maintained. At least that's what I would take this from this panel, not that don't do AI. That's my view.
And one of the ways is there are good AI examples in every industry, in your everyday life. So in every industry, you can find a peer company, a use case that is running on AI, whether you know it or not. So that forms the basis of convincing people to take up the first step.
Unfortunately, I think we ran out of time. So thank you so much to all our panelists today. That was really insightful and very valuable. Please give them a round of applause. Thank you.